we're going to use the product rule to work this problem, and we're going to not only be finding the first derivative, but the second derivative. So I'm going to rewrite our function w, and I'll have 5 z to the second times e to the z. So that will help you recognize what the factors are. So for the first derivative, we find the derivative of the first factor. So that will give us the 5 times the exponent 2 z times the second e to the z plus the first, which is 5 z to the second times the derivative of the second, which is e to the z. And I'll just remind you that I am using the product rule. So when I combine it, the 5 times 2 gives me 10 z times e to the z plus 5 z to the second e to the z. Now that is your first derivative. We want to find the second derivative, so I'm going to go another step. I'm going to start by working with this first term, and so I'll split it into 2 factors like I did at the beginning. So the derivative, we're going to use the product rule again. So the derivative of 10z is just 10 times the second factor, which is e to the z, plus the first, which is 10z, times the derivative of the second factor, which is e to the z. Now I'm going to move over here, and again we're going to use the product rule. So the product rule for 5z to the second, we need to find the derivative of that, and that is 10 because of the 5 times 2 z times the second, which is e to the z, plus the first, 5z to the second, times the derivative of the second, which is e to the z. Now I'm just going to clean it up here a little bit. So we'll have 10 e to the z plus 10 z e to the z, then plus 10 z e to the z, plus 5 z to the second e to the z. We're going to look to see if we have any like terms to combine, and we do right here. And so our d2w over dz squared, which is the same as the second derivative, is 10 e to the z plus 20, because the 10 plus 10, z e to the z plus 5 z to the second e to the z. And that is your second derivative.